Welcome to this Forge College Explainer. Today, we're tackling the very last leg of our journey, finalizing an event-driven smart contract. You spent the last several modules painstakingly designing, wiring up, and testing the engine of your decentralized application. And right now, well, we're finally putting on our virtual hard hats, tightening up those last few bolts, and getting this machine completely ready for the real world. Let's just jump right in, shall we?
So just looking at our overall engineering timeline for a second, we're basically bridging the gap between our previous lesson, which covered validation and observability, straight into this final assembly phase. I mean, think about it. Days ago, we were sketching out event schemas. Just hours ago, we were wiring up the logic. And in our last session, we were running all those targeted tests. And now it's time to actually synthesize all of those isolated little pieces into one single cohesive artifact. Something that front-end devs, indexers, and auditors are just going to absolutely tear into.
Okay, here's our official inspector's clipboard for today. We'll be hitting the assembly line finale, passing quality assurance, writing the instruction manual, signing off on the inspection certificate, and finally, boxing the whole thing up for shipment.
All right, stepping onto the factory floor for part 1, the assembly line finale, where we are looking for full event coverage.
Now, you might be wondering, what's the golden rule here? Well, it's pretty simple, actually. Every single state change needs an event. Honestly, if your contract changes state without emitting an event, it is literally exactly like a bank transferring your money, but just flat out refusing to print a receipt, right? It's highly suspicious, completely unobservable off-chain, and just an absolute nightmare for anyone trying to build a UI on top of it. Every state change absolutely must have a corresponding event declaration. So yeah, no ghost transactions allowed here. I mean, unless you're purposely building some kind of haunted dApp, but that's a whole different course.
Moving swiftly down the line, we hit Section 2, passing quality assurance, where we rigorously inspect our parameters. To actually pass QA, we have to systematically cross-check our code against the schema. So a quick pro tip here, just keep your schema file open on one monitor and your contract on the other. You really want to make sure your indexed fields match up perfectly. And crucially, you need to guarantee that your events are firing in a reliable, deterministic sequence. Like, if a function changes a user's balance and then updates an admin right after, your logs need to reflect that exact chronological order in the receipt. Every single time.
This whole process really highlights why indexed fields are so vital. Think of unindexed events as this massive, messy pile of loose gears. Sure, all the parts are technically there, but trying to find one specific transaction in that pile, it takes forever. Properly indexed fields, on the other hand, act like neatly sorted, beautifully labeled filing cabinets. External machines can just instantly search through these topics without having to decode every single piece of data. It saves a ton of processing power, and honestly, more importantly, it stops front-end developers from yelling at you on Discord.
Okay, up next is Section 3, the instruction manual, also known as your integration notes.
Because listen, a beautifully engineered machine is utterly useless without a proper manual. Your integration blueprint, which usually lives right in your README, needs to map each event directly to its primary consumer and its payload shape. For example, a balance updated event maps to an indexer that's expecting an old and a new balance. An admin action event, that maps straight to an audit worker. By providing a quick JSON example of the expected log payload for every event, off-chain indexers know exactly what data is coming their way. It completely eliminates all that integration guesswork. Which brings us to Section 4, the inspection certificate, or what we call the debug report.
Look, I know we all notoriously dislike writing documentation, right? We'd much rather write 1,000 lines of complex logic than one single paragraph of plain English. But this report is absolutely crucial. It acts as your official inspection certificate. It proves that we ran the tests, that we heard those weird engine noises, like mismatched parameter types, and that we actually fixed them. It answers that fundamental question: did you break it during testing, and exactly how did you fix it?
So what goes in it? Well, your report has to clearly document the validation tests you ran. You'll want to show the before and after of any failing tests. If an event assertion failed because, say, your topics were out of order, document that. Just jot down the corrective action you took and provide the final transaction receipt proving that it now works. Literally just paste that passing JSON receipt right into your markdown file as your hard evidence. Easy. Finally, we arrive at Section 5. Boxing up for shipment, where we assemble the final package. Having passed all of our inspections, it's time to box up this repository. You want to ensure your final delivery package contains all of these exact components: your pristine code in capstone.sol,
your schema in schema.md, your test suite in eventtests.js, your instruction manual in the README, and of course your inspection certificate in report.md. Oh, and if you're using CI/CD pipelines, definitely make sure your tests are running on push. Putting this structure together, it's a real game changer. It turns a simple codebase into a fully reviewable masterpiece.
And right as you tape that box shut, just remember the 3 golden rules of event-driven architecture. Rule 1. Map your events to concrete external needs. Basically, every single emit has to justify its own existence. Rule 2. Treat indexed fields as incredibly strict contracts between your on-chain code and your off-chain watchers. And Rule 3. Always use deterministic placement. Emit order absolutely matters for trace alignment.
You know, there's a well-known idea that really hits the nail on the head. A finalized, clean, event-driven contract is the perfect candidate for modularization. Because you've cleanly separated and validated all your events, refactoring this monolithic contract into composable pieces later on is going to be an absolute breeze. That's actually our next adventure in this track, an introduction to inheritance in Solidity. Good architecture today makes for incredibly easy scaling tomorrow, for sure.
So the final question to ask yourself before you hit submit is this. If a smart contract executes in the forest and there are absolutely no off-chain indexers around to listen to its events, did it really happen? All right, thank you so much for joining this Forge College Explainer. I really hope this structured breakdown helps you finalize your capstone with absolute confidence. If you want to dive deeper, validate your code, and master even more Web3 skills, be sure to visit forge.college today. Keep building, keep testing, and I will see you in the next explainer.